All right, so for the first question in the section, what they want to know is, or well, let's just read it. It says the table models the function m. All right, where x is a function of where m is a function of x, and there's the table of values, and then there's another function n represents a cubic function. Okay, so that's kind of an important detail. Cubic. Cubic means that it is x cubed. All right. So I don't know what m of x is, and I don't know, but I don't. I mean, I can figure it out, but I don't know if it's linear or whatever. So, anyways, this is a cubic function that passes through -0 or -1 comma 0. So now remember that when y is equal to 0, that is the x-intercept. And when x is equal to 0, because remember this is written in x comma y, that when x equals 0, that is what we call the y-intercept. So they gave us the x and y-intercept. Now, if I wanted to compare, so here's how my mind thinks. I haven't even finished reading the question. But they gave us the x and y-intercept. The name of this thing is comparing functions. So I need to identify what are the x and y-intercept of this function. So this is when x equals 0, right? So this is the y-intercept. And this one here is when y equals 0. So this would be what we call the x-intercept. Okay, so that's where it's crossing the x and y axis. All right, so now it says which statement is true. Well, it says that the y-intercept of m is less than the y-intercept of n. So what is the y-intercept of this one? Well, it's 2. So in other words, when I say n of 0, it's equal to 2, but m of 0 is equal to -6. So it's saying that the y-intercept of m is less than the y-intercept of n. Yeah, that's true. That's it right there. Hey, we got lucky. It was the very first one. And that's it. That's all you got to do.